Hello and welcome to Technophen. In this one, we're going to check out Windows Imaging Format, or WIM for short. WIM was developed by Microsoft in the Windows Vista era. It is a file-based disk image format, and its main purpose is to deploy a pre-configured Windows operating system to one or more computers. But it also can archive any file type, and it can be made bootable. For compression, WIM uses three families of LZ77 based algorithms. It has three levels for compression that we can use: none, which does not reduce the final archive size, fast, and max. To create a WIM file, you can use DISM, or Deployment Image Service and Management Tool, which was introduced in Windows 7. However, before Windows 8, DISM was incapable of creating a WIM file on its own and required another tool called ImageX, which is now deprecated. But since Windows 8, you only need DISM, which is included in every modern Windows versions. Just a quick note before we get into the charts. We talked about our method and our test bench in the previous video, which was about ZPack. So if you want to learn more, you can check that video. For our testing, we used the most recent version of DISM, which is built into Windows and up to date if you have installed the latest Windows updates. The space-saving chart shows that setting compression to none results in only 0.22% of space saving. The fast level, on the other hand, saves 17.8% of space, while the max level increases this figure to 18.5%. Looking at the compression time chart, we see WIM is pretty fast. With non-compression, it processed all files in 8.9 seconds, with fast at 10.9 seconds and max compression at 25.2 seconds. Note that the fast compression takes nearly 2 seconds longer to process compared to non-compression, yet delivers a lot of compression. It makes sense to use fast instead of none, as it's nearly as quick and does offer some space saving. Also, the max level is taking more than double the amount of time for processing compared to fast, yet just delivers a 1% uplift in space saving. I believe we can conclude that fast compression of WIM is the best of both worlds here, fast and powerful. Next, onto the processing speed chart. None starts the chart with 200 megabytes per second for compression and 92 megabytes per second for decompression. The fast level reduces the compression speed to 164, but decompression increases slightly. Finally, the max level sees the most reduction in compression speed, at around 71 megabytes per second. Yet, decompression speed is hovering the same as before. We can conclude that the compression method has little effect on decompression speed in this case. This chart shows the compression efficiency score, because none, as the name says, delivers little to no compression. It just doesn't have a good score on efficiency, 0.02. And it should not, because that's why it's made for, to not compress. Moving on to the fast level, we see a fantastic result. Fast got a 1.64 score in efficiency, which is significantly higher compared to the ZPack that we tested previously, and max received a score of 0.73. WIM at fast compression is simply superior to the other two options. As we progress and benchmark more and more tools and formats, we thought it would be a good idea to show an overall chart of each category, highlighting and comparing only the best performers. So this section is for that. These charts currently look so empty, but over time, as we process more data, they will become updated and shown at the end of each video. In the space-saving chart, ZPack's best, level 4 at block size 11, is more effective in compression at 30% against WIM with the max level at 18.5%. Until now, ZPack has held the top spot in space savings. In the efficiency chart, WIM at the fast level outperforms the best result from Z-Pack with a 1.64 score. It's more efficient than Z-Pack Level 1 with block size set to 3 at 1.14. So currently our efficiency king is WIM with compression set to fast. Thank you for watching. Hit the like button, drop us a comment if you want, and see you next time.